Welcome to the Intelligent Business Show, a podcast from Aberdeen discussing the latest trends to keep you and your business at the top of your class. And now, here's your host, Aberdeen's CMO in residence, Matthew Grant.
Hello, and welcome to the Intelligent Business Show, the podcast that focuses on all the ways organizations just like yours use data to make their businesses more intelligent. I'm your host, Matthew Grant, CMO in residence here at Aberdeen. This week, we're speaking with Razat Gaurav, CEO at Llamasoft. Llamasoft breaks down functional silos and disrupts outdated approaches to supply chain decision-making by putting the power of understanding at everyone's fingertips, enabling organizations to quickly make smarter decisions risk-free in a parallel digital world. I was curious about this parallel digital world, how it gets created, and what you can do with it, so I invited Razat to the show. Let's dive in. So, Razat, thanks for joining us here on the Intelligent Business Show.
Great, Matt. Thanks for having me.
Yeah, sure. No problem. So we're going to be talking today about bringing intelligence to the supply chain, but I want to talk start at kind of a higher level and really talk about what are the challenges that companies face when they're trying to do this. So given the incredible amounts of data and computing power available to companies today, what gets in their way when applying it to their supply chain?
Yeah, I think it's a few different things. If you think about the way supply chain as a function has evolved over the last 25 to 30 years, we've come a long way. And most organizations today have oriented themselves and organized themselves in the supply chain function along specific sub-teams that follow what many people in the industry know as the SCORE model. Okay, so you've got a sourcing team, you've got a production team or manufacturing team, you've typically got a distribution team, a transportation team, and sometimes a customer fulfillment organization. And this follows the SCORE model of buy, make, move, sell, and then of course then you have the reverse flow as well, which is managing the returns. So that's typically at a high level how a lot of supply chain functions are organized. And the SCORE model brought a lot of value and discipline and helped bring process rigor for each one of those sub-teams or sub-functions. However, one of the biggest issues has been that this sort of structure has also led to a lot of siloed behaviors, a lot of siloed metrics. And over the years, the systems landscape, the supply chain systems landscape has evolved, also mapping to the same silos. And again, while those systems have provided a lot of process efficiencies, automation, and a lot of capabilities, they have reinforced the siloed decision making. So, And again, the data that companies have, of course, resides in a plethora of systems today. So even if you just look at supply chain relevant data, any organization could have anywhere from 10, 15, 20, 100 different systems where that data may reside. And in most cases, companies don't have a single supply chain system of reference. In terms of the data. So, there are different systems of record, which is understandable because companies have a complex and diverse systems landscape, but the data there's no data model or there's no reference model that helps companies understand how these different operational elements really fit together. What are the interdependencies? And so something as fundamental as a lead time, right? It's a very common data element in the supply chain. Is what are the lead times that you're working off of, and lead time as a data entity gets used in making tons of different decisions in the supply chain. That data point could reside in 5 different systems with 5 completely different assumptions, and there is no standardized way of looking at lead times in your supply chain.
Wow.
So no one is short of data. Everyone has more data than they can use, but there is no single supply chain system of reference. And as a result of that, and again, these companies, a lot of these organizations are modeled through these functional silos. So there is little to no enterprise-level decision-making in the supply chain. And when I say that, I'm talking about decisions that require cross-functional trade-offs to be analyzed. So something as simple as, what are the trade-offs between inventory carrying costs and transportation costs and maybe my manufacturing costs? It's very difficult for companies to assess that and determine that based on this current landscape that exists and the organizations that exist in these companies. So that's really the biggest issue, is the siloed behavior, the siloed structures, the lack of a single supply chain system of reference and a data model. And then thirdly, as a result of all of this, the lack of an enterprise-wide decision-making framework. And as a result of all of this, what happens is, even though the data exists, you're not necessarily being able to monetize or get value from that data in making smarter and faster decisions as an organization, right? And so that's really the biggest gap or the biggest pain point I see in the market today.
Wow. So it's kind of fascinating. I mean, I want to get into kind of how companies solve those problems in a second, but it's funny that the way you're describing this to me, it almost makes it seem like a miracle that things get built and sold and distributed at all. Like, I mean, especially when you now have global supply chains, super complex processes and all these other things. It's kind of crazy that you're saying that. In a sense, I understand that if once you have a functional model, like the SCORE model you were talking about, which allows people to highly optimize specific functions within the process. And then, of course, as they're selling, they buy technologies that actually address their specific functions. And now suddenly you have a fragmented landscape of technology, as you were describing. But it's really strange, even with things like process optimization thinking. Again, it's been going on now 20 years or something like that, that there hasn't been more of a innovation there, I guess, around a kind of meta system, as you were talking about, a system of reference that would allow you to look at the whole thing as holistically, as an integrated system, so you could actually start making these high-level trade-off decisions. I mean, why is that, Razat?
Yeah, look, I mean, at the end of the day, companies do sell their products. They do manufacture their products.
Yeah, no, it works.
Their products, right? It works. I think the question becomes, at what cost?
Right.
With what level of efficiency? At what price? Right? And therein lies the challenge, but also the opportunity. Right? And that's what we in the supply chain world are also focused about, and what we, at Llamasoft are very passionate about is, how can you monetize that data to drive smarter decisions? Decisions are being made today.
Right.
But I can tell you the most common decision-making tool in the supply chain world today is the Microsoft Excel.
Oh, perfect.
Okay, by far. Okay, and so the question is, I mean, again, the question is not that how the heck are these companies functioning? They're functioning today. They work. And they operate. But the question is, what is the opportunity for them to function in a smarter way? Right? How can they function in a more profitable way, in a more efficient way? How can they function in a way that they can provide better service levels to their customers? Right? That's the key question. And so therein lies the opportunity. But to answer your question on why has this not happened up to this point, it's a good question. But I think that's where this is an evolutionary path. Right? And some of the reasons for this has to do with the way the supply chain, function has evolved, or the supply chain discipline, supply chain management as a discipline has evolved. Right? I mean, the word supply chain management did not exist 50 years ago. Right? People can debate exactly when it came about, but it was more in sort of the 30, 35-year time horizon is when this terminology came into play. Before that, people talked about logistics, people talked about
Yes.
manufacturing,
Yes.
people talked about procurement, right?
Right.
But the discipline is fairly nascent, is fairly young in terms of the runway compared to a lot of other disciplines. You know, we've had engineers, we've had structural engineers for
1,000
years.
Yeah, right, 2,000
Right,
years.
right.
Yep.
But we've only had supply chain professionals that are looking at this across the board for a very short tenure. So part of it is evolutionary from that perspective. The other reason is it has to do with technology.
Yep.
Right. I think most companies, as they've adopted IT systems for managing their business, could be ERP systems, could be systems for managing, for figuring out their demand plans, or for managing their warehouses, or for managing their fleets, or for managing their procurement processes. They've been doing that again in an evolutionary way. And frankly, there's a very diverse range of maturity levels where companies are today, even in just adopting those first principles that the SCORE model outlined, and the following systems projects that resulted in companies adopting those systems, right?
Right.
So there's still many companies that are in that first phase of evolution. Now, there are many companies that have already done that and are now looking for the next wave of evolution and innovation, where they are looking now at decisions that can be made at an enterprise level, and they're developing centers of excellence. So I think part of it is also the evolution of how systems have been rolled out over time.
Yep.
The third reason is also just computing horsepower, right? We've had optimization technologies, we've had machine learning algorithms for 30, 40 years, right? But to realistically solve an optimization problem or machine learning problem, that is applied to the supply chain world. Supply chain world has a lot of complex trade-offs. It has a lot of complex operational constraints. So when you're running these algorithms and when you're creating these mathematical models, they cannot just be very high level and aggregated. They need to be reflective of the operational complexity and the details that actually are existent in that physical world. Right? So the permutations, the combinations, and the constraints get very complex. So, crunching through these algorithms, through the data sets, what would take about 12, 13, 14 hours, let's say 15 years ago, today can be done in a few seconds or minutes. Right?
Right.
Now, that's game-changing. Right?
Totally.
And cloud computing is enabling that.
Right.
So the computing horsepower is another reason. And so when you're looking at enterprise-wide level supply chain decision-making, looking at these complex trade-offs, you have to be able to have the computing horsepower to evaluate those data sets and the operational constraints that surround them. We didn't have that 15 years ago. We didn't even have that 5 years ago, by the way. Even if I see where we've come in the last 3 to 5 years to now, it's incredible, right? So I think it's a combination of factors why it's not there in place in most organizations. But again, the exciting thing is that now with the computing horsepower, the evolution and the adoption of the first wave of systems already in place, and the availability of data, and of course the decision sciences and the data sciences and the operations research, the math behind these have evolved and improved as well. I think we can be doing a lot more than we have in the past.
No. And I think it's interesting way once you frame it in that sense. Like, you can't even optimize an entire system until you first conceptualized it as an entire system. So even like you were saying, supply chain management, if that didn't exist, if it was split up into logistics and all these other pieces before, you didn't even have a whole problem to solve until that framework is in place. Plus the technology, now the enabling technology in terms of computing power is there. So we're kind of living in a golden moment. So, and this, to my mind, at least how you've described it, is where Llamasoft comes in. So it's my understanding that you're taking advantage of all this computing power in some ways to use to create digital twins of the supply chain so that you can then use that digital twin for modeling and forecasting things happening in a given company's supply chain. So could you, fill us in on that? How does define for people who, if they don't know what a digital twin is, what that means and kind of how this works?
Yeah, absolutely. So we at Llamasoft, what we do is, our platform enables companies to take data and they're able to model their supply chain, their end-to-end supply chain, all the way from sourcing into production and manufacturing, into distribution, transportation, logistics, and ultimately to fulfillment. And they're able to model that supply chain using real-world data, and they can reflect those operational complexities and the constraints that exist down to the line level detail in a production facility, or down to the dock doors in a warehouse, or down to duties and taxes and tariffs, which, as you know, today are getting more and more complex. Definitely. With some of the political changes and the policy changes that are happening there. So we provide the ability for companies to take real-world data and reflect the operational complexities of their supply chain from an end-to-end perspective in one single product, in one single data model.
Yep.
Okay? So that data model is broad enough to represent the supply chain, but it's also granular enough to reflect the complexities of the supply chain, so it's credible. So that's the first thing we do, and that's what I mean by the digital twin of the supply chain, is we are able to help companies establish that digital twin. Now you have the sandbox, and then we provide the capabilities, the modeling capabilities, and the decisioning capabilities to look at playing out all kinds of scenarios and what-ifs to help facilitate decision-making. And that decision-making, like I said, could be in a given silo of the supply chain. It could be across those silos. And it could be across those silos of time horizon as well. That's the other thing that has happened in the past, is that we artificially separated out decisions that you make at a strategic level versus tactical level versus day-to-day, operational execution level.
Yep.
Well, in today's day and age, with the type of data that's available, with the type of technologies that are available, you should be able to have a single decision-making platform that you can use across those functional silos, but also across the silos of time horizons, right? Mm-hmm. And that's what we do, is we enable that. And then we have a really innovative and cool capability that we are right now in early adoption mode, where once you've made the decision, then the big topic then is, okay, how do you operationalize the decisions?
Yeah.
Right? How do you execute on them? Because it's not enough just to analyze, right? And so we're in the process right now of launching in the market, and we're doing some early adopter projects on this with some very large organizations around the world, both in retail and in manufacturing, to allow them to develop micro apps very rapidly that are able to operationalize the decisions that you've made, and to be able to roll those out or to execute them or implement them across your broader organization in a very rapid time frame. And to do that in a way that doesn't require for you to rip and replace your existing IT landscape, because that's a very complex landscape.
Totally.
But is done in a way that can fit into an existing IT landscape and can integrate seamlessly into that existing landscape, right? Wow. So that's really our capabilities here. Is we look at our solution as being a digital design and decisioning platform for the supply chain. So a digital design and decisioning platform for the supply chain. And in doing so, we're providing you the capability to create a digital twin of the supply chain with all the breadth and the complexities, the granular complexities of your supply chain.
Yep.
Then we're providing you the analytical capabilities to make trade-off decisions and the what-if analysis across functional silos and across time horizons. And then we're providing you a platform to operationalize those decisions in a very, very rapid time frame across your broader organization.
Right.
Okay.
So I have a couple of questions. You've said I'm very interested in finding out some of the more of the details about this. But so my first question though has to do with, so you're modeling the supply chain, and you said in a very granular way for companies. I'm assuming on some level, even just the modeling process itself can reveal either organizational weaknesses or opportunities where, I don't know, like, I guess what I was thinking was, in order for you to create the model, you need the data. As you were describing before, companies have data in all these siloed areas and stuff like that. In fact, and the data is not even talking to each other. So I'm just wondering if even in the modeling process itself, companies end up having to either address or surface these data holes or gaps or blind spots that they might have. Am I getting that right?
Yeah, that's a very good point. It's interesting you say that because during the modeling process, but also during the, once you've modeled your network, and before you even start doing all the analysis and the decisioning, right? Even just visualizing your supply chain,
Yep.
sometimes provides all kinds of insights on gaps, on holes, on bottlenecks that you may not have thought through because you haven't really looked at that digital twin of your supply chain from that perspective.
Yep.
It's similar to the point of view that, when you're, on a road, on a street in the city, you get a certain perspective, but when you look at the aerial view,
Yep.
sometimes you get a whole different perspective, right?
Oh, yeah.
And you notice things that you may not have noticed when you were down on that street level.
Right.
So you're absolutely right, and so just the prescriptive task of creating this digital model or the digital equivalent provides a lot of value in itself.
Yep.
Right.
Yep.
And then of course beyond that, you can help do a lot of the analytics around this, but that in itself, what we've seen with customers is of huge value.
Yeah, I mean, I've seen that. I did a short stint as a consultant here, where we were going into creative services departments in large corporations and doing process mapping and stuff like that. And it's interesting just having a third party come in and map of the process automatically shows people where they weren't thinking things or where they have missed opportunities or redundant processes or whatever.
Yes.
But so the other thing I did want to ask, though, was when you were talking about this operationalizing things through the micro apps. I don't know if, again, you said that's the early adopter phase, but it got me thinking about, do you have a story or two of things that companies have been able to do either to optimize or create new efficiencies in their supply chain through using this Llamasoft sort of digital twin approach?
Yeah, lots of great stories and lots of great examples. We have about 675 customers globally across just about every subsegment of manufacturing and retail. But I can take a few sample cases which may be interesting for you, right? And again, I'll share some case studies that are more commonly known because our customers have been willing to share those publicly. But
Fair
some
enough.
of them I'll talk in anonymous terms, but at least it outline the use cases,
Sure.
right?
Uh-huh.
So one great example of this, for example, is what we're doing with one of the largest furniture retailers in the world, okay, where they have a very global, very complex network of stores and distribution networks, and they have a very diverse supplier base. Some of those suppliers are captive, some of them are third-party manufacturers, some of them are in-house, manufactured. So it's a very broad and complex supplier base.
Yep.
And that supplier base is very geographically distributed as well. So they're all over the Far East, Europe, Latin America, North America, etc. And they've got a very, very complex SKU base, so over 5 million SKUs, if
Holy
you would.
cow.
And so they worked with us, and one of their key challenges was, because they have a many-to-many network on their inbound supply side. What I mean by that is, several different suppliers could supply the same product category or the same merchandise and could fulfill in many different parts of their network or their store network, right? Yep. So you're trying to make decisions on what's the best supplier to source from for a given set of orders, right? For a given set of product categories.
Yep.
And so we worked with them, and they leveraged, again, our underlying data model and our algorithm library to create a very sophisticated total landed cost engine, right, where they were able to model their supplier base globally, their store networks globally, their distribution networks, so all the different echelons or all the different tiers of their supply chain, and were then working with, so that was part of what they did to create that digital twin, if you would, for this use case. And then they went down to the granular levels of detail of modeling their transportation costs, their inventory carrying costs, and inventory carrying costs vary again by product categories. For example, they modeled in detail duties and tariffs because depending on the changing policies. Tariffs, for example, for them could account for anywhere from 10 to 40% of their total cost of goods sold.
Holy wow!
Right, so it can have a material impact on where you source from. And we did all of this, and now their merchandising team, over 800 users in their merchandising team all over the world, uses the solution to make ongoing decisions on what items to source from what suppliers, taking into account this very sophisticated total landed cost engine.
Right. Wow.
Okay. And this is not something that they use once a year or once in 2 years. They do this on a daily, weekly basis, right, on an ongoing basis to fulfill specific store orders. So that's a really good example because it talks about the level of the global complexity that they had, and taking into account different functional elements of transportation and inventory and duties and tariffs in making those decisions.
Yeah.
Another example is
actually, if you I'm sorry, just to interrupt you there, just only because there was a lot going on in that story. And I think you were right in terms of illustrating just how complex supply chain can get. But also, it was reminding me a little bit of Moneyball, where I'm sure what you're able to find is there are different dimensions that you could use to look at your different suppliers, and by even finding sort of hidden dimensions that might actually allow you to rank them in a more efficient, more cost-effective manner. But you can't even get there until you've modeled it in the level of detail that you guys have to do in order to in order to create the digital twin.
Right.
So
you're totally right, and in fact. In another example, again, similar sourcing use case, we had the customer actually not just model in these different cost elements, but also they factored in quality and risk elements.
Oh, wow.
Okay? Because what they found was that when they scorecarded their supplier base, not every supplier was consistent in terms of their ability to fulfill on time with the right quantities on a consistent basis, right? So they added an element of quality and risk, as one of the factors that fed into the total landed cost engine,
Yep.
right? And then we've done some really sophisticated things with them in being able to use some stochastic models and being able to look at what the distribution curve would be of that particular supplier based on real data
Yep.
on their ability to fulfill the orders that they were looking at. So a lot of this is, ultimately it's all about, and this is where I'll say this customer that I talked about has done an incredibly good job of developing the skills and the talent base.
Right.
We helped. We had a partner help, a consulting partner help as well to do this. But they've done a good job of developing in-house skills of people who can understand the business constructs and the operational elements in that physical supply chain,
Yep.
but are able then to also do the modeling in the digital world, right? And I can tell you the need for that skill set that can marry the physical and the digital world, the need for that type of talent in the supply chain is going to get more and more important as we go forward.
Yeah.
Okay. And I can tell you right now, I see that as a huge risk element in the ability as an industry for us to take advantage of all this data that we talked about in the beginning of the call.
Yeah.
Okay? Because everyone is talking about AI and everyone's talking about ML and, yes, there's a lot of value in leveraging those algorithms. But if you don't have the right people who can marry the physical and the digital world, they're not going to be able to know how to monetize and how to get value from these algorithms.
Right.
Right? And so the need for that talent is going to get more and more pronounced. And in fact, we feel really passionate about that at Llamasoft. And we're not just sitting behind and sort of complaining about it.
Yep.
We're actually going in and we are partnering, with some key universities like the University of Michigan and MIT and Georgia Tech and others,
Nice.
to really go deep in helping these universities incorporate our product into their curriculum, so the students have some hands-on experience in doing the type of work I'm talking about as they develop these skills.
Yep.
We're tripling the size of our internship program next year. And as these students are graduating, who have gone through this curriculum and the internship program, we want to make the talent pool, the students who are graduating, available not just to ourselves, but to our entire ecosystem of customers and partners.
Yeah.
Right?
Yeah.
Because I see the talent element of this being a very, very critical success factor in us being able to get value from these solutions.
No, I think that makes a lot of sense because, frankly, if you're starting to make more and more decisions based on the digital model has to be fairly congruent, as close as possible to the contours of reality, because every gap between the model and reality is itself a point of risk. So I was curious. And that also, I think, moving kind of downstream into the talent pool and getting tools and stuff in the hands of students, that makes perfect sense to me. So the last question, though, I started thinking about this when you were talking about kind of developing a predictive engine to assess the capabilities of your suppliers and stuff like that. And even what we started talking about at the top, this notion of really seeing your whole supply chain holistically, it starts to raise the question of, and you see this with like you were even saying, companies that have kind of captive suppliers and things like that. At a certain point, the point of unpredictability becomes whatever's outside your company. And I can imagine organizations are trying more and more to figure out, how can I control what's even happening within my suppliers? Because that itself is going to have a big impact on what I'm able to do with my supply chain. And that in turn, I would imagine, is forcing suppliers and other, manufacturers or part manufacturers, transportation companies to become themselves more data-driven and more intelligent in how they approach operations. I was just wondering if you're seeing this added effect as the supply chain management becomes more intelligent, data-driven, is that pushing everyone who's touching the supply chain to kind of follow suit?
Yeah, supply chain by its very nature involves a lot of different entities.
Yes.
Right? And those are various entities within your one organization. So, you typically have all the different functions we talked about across sourcing and manufacturing and distribution, and if you're in retail, into store fulfillment, etc.
Yep.
But you also touch other parts of the organization, like finance, like sales, but those entities, there are also a lot of interdependencies with entities outside of your own organization. Right? So you're working with carriers, you're working with suppliers, you're working with customers. So by its very nature, there is a network of entities, and there's a network of people who really come together to make that supply chain function. Right? So as you're looking at data and you're looking at making decisions that are data-driven, you cannot only look at data from within your own enterprise, right? And this is something that has been a challenge where a lot of companies have been inside-out driven, wherein, really there's a need for an outside-in perspective and an outside-in approach to managing your supply chain. And, there's been a buzzword in the industry that has existed for 15, 20 years now of being a demand-driven supply chain, right? But demand, the ultimate source of demand is typically not in your own organization. It's outside in the market. It's your customers, right? Or sometimes it's your customer's customer.
Right.
So an outside-in approach to managing the supply chain is very important. So, and we've seen this, to give it some real-world example, right? We've seen this because we recently created a new innovation around helping companies with modeling their demand forecasts and figuring out how could they improve on forecast accuracy, right? And demand planning has been done and forecasting has been done for years and years. And there's some very standardized techniques to help with that. There's been some innovation in there, and a lot of those have been statistical methods. A lot of those statistical methods today are being labeled as AI, which is fine, right? But when our team looked at this and working with some large organizations, what they found was that the inputs into figuring out the forecast were sometimes they were just looking at data within their own enterprise. They were looking at their sales data, they were looking at some, historical data, etc. And they were missing the point and understanding that, even things like macroeconomic indicators like GDP or employment rate or housing rates, some of these macroeconomic indicators from a market perspective can have a huge impact on the forecast and the demand. And there's a strong correlation between the two, right? And so we took an outside-in approach to this, and we created, a market-driven approach to doing demand planning for the midterm and the long term. And then we used some very interesting, standard open-source machine learning algorithms to model what attributes to look at to determine the forecast. So let the data determine and self-realize or reveal the attributes to look at, as opposed to just relying on the same human being. And what we found was that we could improve forecast accuracy levels by 15, sometimes 30%.
Holy cow.
And forecast accuracy improvement of those levels, I mean, when you translate the impact on companies, it's huge because the way companies, no forecast is going to be 100% accurate unless you fluke it, right? Typically. So the way companies deal with the gap between, or how they deal with the inaccuracies in the forecast. You still need a forecast because you've got to plan your operations. There's something called a lead time. Not everything can be real time, right? Despite all the machine learning and the AI stuff, there's still something called a physical lead time, right? To get inventory from Shenzhen to a warehouse in Alabama, it still takes you 12 to 17 days,
Yep.
right?
Yeah.
Or if you're air freighting, it'll still take you overnight, right? So you've got to plan for it, which means you need to forecast. So a forecast is important, but the way the companies deal with the inaccuracy is that they put buffer inventory.
Right.
So the less accurate your forecast, the higher your levels of buffer inventory.
Right.
Okay? And that buffer inventory, of course, leads to working capital on your balance sheet.
Yep.
Right? So if you can improve the forecast accuracy by 1%, you should be able to significantly drop your buffer inventory and hence reduce your working capital on your balance sheet.
Right.
Right? So when we look at these kinds of results where, companies are able to improve their forecast accuracy by 10% or 30%, it has profound, huge impact, like CEO and boardroom level impact on companies' balance sheets, right? So, but that outside-in approach of using both data available within your own organization, but also external market data. There's some similar use cases that we are seeing with using social sentiments, for example, or social media data, right? Or using, data that's coming from some companies that are aggregating and creating, insights for specific industries. A lot of this outside-in data, or in some cases using weather data, right? Because weather sometimes can be a huge driver to demand for certain products. Can have a profound impact on your decision making and definitely on your demand plans.
Nice. Wow. So this has been fascinating, Razat. And again, I know enough about supply chain to be dangerous. I feel like you've really gotten into just how complex it is and how challenging it is for all the supply chain managers out there. Hats off to you. So thank you once again for joining us on the Intelligent Business Show.
Great. Thanks so much, Matt. Good talking to you.
All right. Thanks. All right, everybody. Thanks for listening. Be sure to tune in next week where our guest will be Brad Killinger, CEO at Sapiens. You won't want to miss it. See you then.
Thanks for listening to this episode of the Intelligent Business Show. You can find this show on iTunes and Spotify, as well as on YouTube. And be sure to follow us on Twitter at Aberdeen_show. And if you want to know what's going on in your market space, be sure to check out Aberdeen.com.